Hello everyone. In this video, we're going to talk about how we can create an equation based on the graph of a trig function. So we're going to go over a couple examples here, and you'll be able to understand how we can determine the equation. So one of the first things we should do first is to determine whether or not we want to deal with a sine function, which looks like this, where the first cycle starts in the midline. It goes up to the maximum, the minimum, and then back to the midline here. Or we can try and see if we want to describe a cosine function, where in this case, instead of starting on the midline, it actually starts in the maximum value. So it starts at a maximum value, it goes down past the midline, and goes back up to the same exact value of the maximum here. Okay, so in this first example here, let's try doing a cosine function in this case. So here we can see that we want our cycle to start here. Right over here, this is the end of our cycle. So if I were to draw a little box, this will capture one entire cycle of a cosine graph, as you can see here. Okay, so this is all we really need to determine the equation of our cosine function. So some of the components, as you can see, this is the entire function that we need. And some of the parameters we need, of course, is amplitude, which is valued as a. Period, we're going to denote this as c. And as you can see, it's actually not in our parent function here, or our graphing form. B, of course, we need that. That's in our equation here. And we need h and k. And we'll discuss what those exactly mean. So first things first, amplitude here is the distance between the midline and the max or minimum value. So what that represents is if this is the maximum value here, right? And as you can see, the middle happens to be at y equals 0, so that there is coincidental here. So this distance from the maximum value to this midline here is represented as our a value. And as you can see, if it starts at 0, the midline, 0, 1, 2, 3, that's going to be our amplitude. So in this case, a is going to be 3. Okay? So that's already one parameter down. So period here, by definition, this is the length of one cycle. So as you recall here, this length that I have here, the distance from the starting point to the end point, that's the length of one period. Okay, so in this particular case, it looks like our equation starts at 0, at x equals 0, right over here, but it also ends at x equals 2 pi. So this is our endpoint. This is our starting point here. So simple algebra tells us that, okay, our period length is just going to be the end minus the start, which in this case is going to be 2 pi minus 0, which in this case is just going to be 2 pi, right? So there we have not a parameter, but a value that we can actually use to determine the one other parameter in the equation here. In this case, we're going to be talking about b. B, by definition, is the number of cycles within 2 pi. So in this particular case, I might be thinking, okay, how many cycles are within 2 pi? The actual formula we need to actually determine what b is this formula here. It's going to be 2 pi divided by our c, which, remember, is the period length here. So if our c is 2 pi, all I need to do is 2 pi divided by 2 pi, which ends up giving us a giant 1 here. Okay, so here we have two parameters already. We have a, and we also have our b value. Okay, so now we need to determine what h and k is, and in this case, something we need to remember, that this is called the locator point, and they are very different for every single function. But in terms of a cosine function, the locator point is always going to be located on the midline. Okay, so it's the intersection between the midline, which is of course the line in between the maximum and the minimum, and also it's going to be the intersection between that and the where exactly the where we actually start here. Okay, so in this case, our h and k value is going to be this point here, and our h, where we start, is actually going to be 0, because that's the x value at 0, and then the k value will also still be 0, because remember, it's located on the midline, and as you can see, the midline here is going to be 0. Okay, so that actually makes things really easy for us. So our h and k is going to be 0, 0. Okay, so now let me go ahead and rewrite this function here. I have y is equal to a times trig bx minus h plus k. And we have a, we have b, we have h, and we have k, so we just gotta plug it in. So our and we also know what trig function we are using. So y is equal to 3 times cosine, because I start at the maximum, so I want to use a cosine. Our b value, we found out it was 1, x minus 0, which is h, plus 0. Okay, so simplified further, just to make it look nice, here I have 3 cosine x, and that's it, right? Because x minus 0 is just x, 1 times x is just x, add 0 does nothing for me. So this right here is the actual equation for this graph here. Okay, so I could do the same thing for this bottom problem here. Okay, so what if instead I wanted to use sine? As you recall here, sine starts on the midline. So the midline is always at the midpoint between our minimum and maximum. So if this is our maximum right up here, our minimum is right down here. As you can see, it's along this line. The midpoint between there is this line here. So what I can do is I can draw the line, the midline here, to kind of help visualize where I should start with sine. So like I said, it starts on the midline, so I can actually create my box from here. So this is where I start, and I draw the top of my box and the bottom of my box, just like that. And it's going to end up at the midline again. So this right here is going to be sine. Okay. So now amplitude, like I said, it's the difference between the midline and also the maximum value, distance between there. So right over here, our distance is just going to be 1. But there's also one component to A that's missing here. As you can see, our original sine graph goes up and then goes down, right? 2 concavities here, 1 up and down, right? But in this particular case, it actually goes down first and up. So the transformation that happened here is that it got reflected over the x-axis, and to do that, essentially, we need to multiply a function by a -1. So our actual amplitude isn't just 1, it's actually going to be negative 1. Okay, and period, as you recall, is going to be the length of one cycle. So if we start here and we end here, this is going to be the length of the period. So it starts at pi, ends at 9 pi. So essentially the period is just going to be 9 pi minus pi, because 9 pi is the end and pi is the start. So in this case, our period, which is a c value, is equal to 8 pi. Okay. And then to find the b value, what we need to do here is to determine what we already have our c value, and we need to use that for our equation, which is, remember, 2 pi divided by c, which in this case we get 2 pi divided by 8 pi, and if we simplify this further, we end up getting 1/4. So that's going to be our b value here. And h, similar to cosine, the h value is, the h and k, the locator point, is always going to be on the midline here. So if our midline is right over here, and it intersects where our starting point is, so our h value is the x value, which is at pi, and the k value is where along the y-axis is our midline. So our midline here, if we go down by 2, that's going to be the y value of our midline. So we end up getting negative pi, or pi, comma, negative 2. So in this case, h and k is pi, negative 2. And that's all of our parameters. Now we just need to write our final equation, which was y is equal to a times trig bx minus h plus k. So a, like we said, was negative 1. The trig function that we are using is sine in this case. The b value we figured out was 1/4. The h is pi. And the k is negative 2. So if you want to simplify this a little bit to make it look nicer, we can end up getting negative sine 1/4 x minus pi minus 2. And that is our final equation. Right? So that, my friends, is how we determine the equation of a given graph of a periodic function or a trig function here. Okay, that's it for today.